exploration of the heavens.
Okay, I've got it on pause, and what you're looking at is a knitting needle. And I happen to have in my crew preference a couple of knitting needles. And not that we have a lot of time to do knitting up here, but there's some other neat things you could do with them. And so watch this. So here I have a piece of paper, and I rub the knitting needle with a piece of paper. And this knit needle is a polyethylene knit needle. It's 8 millimeters in diameter. And now I'm going to take a syringe with a little Teflon cannula. I'm going to squirt drops of water out, and look what happens when those drops of water get close to that charged knit needle. So this is like a little satellite going around a cylindrical-shaped planet. Except the physics here is a little bit different. It's not about gravitation. It's about charge forces. And, of course, charges can exert a potential field, as we call it. So it can exert a force at a distance with no tangible connection. And so you have a charged drop that was ejected from the Teflon-tipped syringe. And then you have the charged knitting needle. And they're going to be attracted if they're opposite charges, but because the drop has some velocity to it, it's orbiting around the knitting needle. Now this knitting needle happens to be a little different than when we started out. This knitting needle is made out of Teflon, and Teflon has some really neat static charges. We have some little tiny droplets. They kind of remind me of flies on a picnic out in Houston.
What are you talking about, you idiot?
Superfluid helium can do things we might have believed impossible. It appears to defy gravity. A thin film can climb walls and escape its container. This is because a superfluid has zero viscosity. It can even produce a frictionless fountain, one that never stops flowing. Superfluidity and superconductivity were baffling concepts for scientists. New radical theories were needed to explain them.
So, with that, let me sign off from my kitchen.